Hello friends, good morning. The last unit, that is testing of electrical equipments, is divided into two parts that I had explained. First one is non-destructive testing and second one is high voltage testing. In my previous few lectures, I have explained non-destructive testings. I have explained what are non-destructive testings, what is the significance of non-destructive testings, what are the limitations or drawbacks of high voltage testings, then the parameters which define the quality of insulation and the parameter which defines the health of the insulation. I had explained how to measure insulation resistance, capacitance, loss factor, and then how to detect the partial discharges and how to measure the partial discharges. Now let us start with the high voltage testing of electrical equipments. In this series of high voltage testing lectures, I will explain how the high voltage testings are performed and what is their significance, what are the stages involved. So let us start with these terms, important terms used in high voltage testing. First, let us see what is the purpose of high voltage testing. High voltage tests are performed to ascertain that the equipment withstands the different overvoltage conditions during service. See, when any equipment is put into the service condition, it is subjected to different types of high voltage conditions. So before putting that equipment into service, it is necessary to check whether the equipment insulation is capable of sustaining all these conditions or not. Therefore, the high voltage testing is performed. In test codes and standard specifications, certain technical terms are used to specify and define conditions or procedures as under. First is AC test voltages. Alternating test voltages of power frequency should have a frequency range of 40 to 60 Hz and should be approximately sinusoidal. See, when we are using power system or in the power system, there is restriction on the frequency of the AC voltage supply. But when we are testing the equipments, it is not directly through the power system equipment, but it is through the testing transformer. So there is some flexibility for the frequency range. It should be between 40 to 60 Hz. Disruptive discharge voltage. This is defined as the voltage which produces the loss of dielectric strength of an insulation. It is that voltage at which the electrical stress in the insulation causes a failure which includes the collapse of the voltage and passage of current. So this includes flashover, sparkover or breakdown, that is also called as puncture. In withstand voltage, the maximum voltage which the test object under specified conditions should withstand for the specified duration without flashover or failure, that is called as withstand voltage. And typical duration for withstand voltage test is 1 minute. So obviously withstand voltage is less than the disruptive discharge voltage. Next is impulse voltage. Impulse voltages are characterized by polarity, peak value, time to front and time to half of the peak value. So this is the waveform. I had already explained you this type of waveform, that is impulse waveform. This is peak value represented by 1 unit. This is the 50% of the peak value. This is represented by 0.5 per unit. This is time T1, that is time to rise to peak value, and T2, that is time to reduce to 50% of the peak value. And as per Indian standard, for lightning over voltage, it is 1.2 by 50 microsecond wave, and for switching over voltage, it is 250 by 2500 microsecond impulse wave. Next is 50% flashover voltage. This is the minimum peak voltage of a standard impulse wave which has a probability of 50% flashover when applied to a test object. Next is 100% flashover voltage. This is the minimum peak voltage of a standard impulse wave that causes a flashover at each of its application under a specified condition when applied to test object. Now here it is important that it is the minimum peak voltage in both the conditions. And obviously the 50% flashover voltage will be less than 100% flashover voltage. Next is three-phase distance. It is the shortest distance on the contour of the external surface of the insulator unit or between two metal fittings on the insulators. For example, Consider a bushing. This is bushing. Now in case of bushing, conductor passes through it. So conductor is taken out from this point P1 and lower part is connected to the transformer or any electrical equipment. So this portion is in touch with the body of the equipment and this is high voltage terminal. Body of the equipment is grounded. So you might have observed the shape of the bushing as well as insulator. It is like this. Now if we measure the vertical distance from this point up to this, that is high voltage point, up to the earth point, that is called as clearance. And when we measure the distance over the contour of this bushing or insulator is from this point like this, like this, like this up to this point. So it is called as creepage distance. Obviously creepage distance is more than clearance. Same thing is here for the pin type insulator. Conductor passes on the top, lower portion is grounded through the pin. So if we measure the vertical distance from this point up to this point, that is called as clearance. And if we measure the distance over the surface complete without any break, that is called as creepage distance. Then reference atmospheric conditions. Temperature should be 27 degrees Celsius. In some cases it is 20 degrees Celsius. Pressure 760 torr. Absolute humidity 17 grams per meter cube. So if test is performed, because when we are performing the test, it is not necessary that these standard conditions are there always. So we have to treat when we are performing the test under some other conditions other than standard conditions. Then we have to use air density correction factor delta to find out the actual value of any voltage. It can be impulse voltage 50%, 100% with a stand flashover, or as well as power frequency voltage. Now types of tests performed on the electrical equipments. The tests that are normally conducted are usually subdivided as type test and routine test. First is type test. These tests are intended to check the design features and the quality. These tests are done on samples when new design or design changes are introduced. Means whenever there is change in the design, then only this type test is performed. Then routine test. These tests are intended to check the quality of the individual test piece. These tests are done to ensure the reliability of the individual test objects and quality and consistency of the materials used in their manufacture. So these routine tests are performed on each and every individual unit. Now let us see what are the different power system equipments which are tested. It is insulators, bushings, isolators, circuit breakers, cables, transformers, lightning arresters. These are different equipments which are tested. Power capacitor is also there. That is also tested for high voltage testing. So let us start with the test on insulators. So here in this diagram, in this slide, I have shown different types of insulators. This is pin type insulator. In case of pin type insulator, conductor is on the top and lower pin is grounded. It is disc type insulator or suspension insulator. Conductor is at the bottom and top pin is grounded. When number of discs are connected in series and they are connected in vertical position, it is called as suspension insulator or string of the insulator. So these are individual units. They are insulators, and these are called cups, and these are the this is lightning arrestor, which is used to protect this string from lightning or voltage. Conductor is at the bottom. This part is connected to the tower. So if there is lightning or voltage, the spark over or flash over will take place in the air between this power conductor. This conductor connected to the power conductor and the tower. When this arrangement is connected in horizontal position, that is called as strain of the insulator, and this is used for at the termination of the line or when line is turning. So here also there are disc, individual strain is protected by means of lightning arresters like this and like this. This is jumper connecting the high voltage conductor of this side to the high voltage conductor of this side. Now let us see what are the different tests which are performed on insulators. First is power frequency test. In this, number one is flashover test. It is the test conducted to determine the power frequency flashover voltage of an insulator. Flashover voltage is the minimum RMS power frequency voltage at which breakdown occurs along the surface of the insulator, that is flashover, when voltage is increased gradually in uniform way. So this should be in the air, not through the insulator, because it is flashover, and condition is voltage should be increased gradually and in uniform way. If the test is conducted under normal conditions without any rain or precipitation, it is called as dry flashover test. If the test is done under conditions of rain, it is called wet flashover test. During wet flashover test, the test object is sprayed with nozzles at an inclination of 45 degrees to the vertical. There is artificial rain making instrument, and through that instrument or that equipment, condition of rain is simulated and water is sprayed at an inclination of 45 degrees to the vertical. Because 45 degrees, because when it is 45 degrees, the accumulation of the water on the surface of the insulators is maximum. The test object is sprayed for at least 1 minute before the voltage application, and the spray is continued during the voltage application. So first it is sprayed for at least 1 minute, and after that, in spraying condition itself, the voltage is applied. Next is wet and dry withstand test, that is 1 minute. In this test, the voltage specified in the relevant specifications is applied under dry or wet conditions for a period of 1 minute with an insulator mounted as in service conditions. The test piece should withstand the specified voltage. Now, the value of the withstand voltage as well as flashover voltage, that depends on the rating of the insulator, and for a particular rating of the insulator like 11 kV, 22 kV, 33 kV, string of 132 kV or string of 132 kV, what should be the flashover voltage, minimum flashover voltage, and what should be the wet and dry withstand voltage, they are given in relevant references. Next is impulse test on insulators. First is impulse withstand voltage test. This test is done by applying standard impulse voltage of a specified value under dry conditions with both positive and negative polarities of the wave. Now how much should be the peak value? That is also decided as per this standard for the given rated value of the insulators. If 5 consecutive waves do not cause a flashover or puncture, the insulator is deemed to have passed the test. If 2 applications cause flashover, the object is deemed to have failed. If there is only one failure, additional 10 applications of the voltage wave are made. If the test object has withstood the subsequent applications, it is said to have passed the test. So this is the standard procedure for impulse withstand voltage test. Then impulse flashover test. The test is done as above with the specified voltage. Usually the probability of failure is determined for 40% and 60% failure values or 20% and 80% failure values, since it is difficult to adjust the test voltage for the exact 50% flashover value. The average value of the upper and the lower limits is taken. The insulator surface should not be damaged by these tests. Now in case of impulse flashover test, it is very difficult to adjust exactly the 50% impulse flashover voltage. Therefore, 2 alternatives are given, 40% and 60% or 20% and 80%. So two values are selected, one lower value say V1 and second upper value say V2. So for the lower value, there should be flashover 4 times out of 10 applications, and for upper value 6 times out of 10 applications, or with lower value should be 2 times out of 10 applications, and for upper value it is 8 times out of 10 applications. Then average of these two values V1 and V2 is taken, and that is called as 50% impulse flashover voltage. Then it is pollution test. At present, there is no standard pollution test available. The popular test that is normally done is the salt fog test. In this test, the maximum normal withstand voltage is applied on the insulator, and then artificial salt fog is created around the insulator by jets of salt water and compressed air. If the flashover occurs within 1 hour, the test is repeated with fog of lower salinity, otherwise with a fog of higher salinity. The maximum salinity at which the insulator withstands 3 out of 4 tests without flashover is taken as the representative figure. Now see, the insulators which are near to the seashore get salt accumulation on the surface. There is salt deposition on the surface of the insulator. Therefore, the probability of failure is more. Similarly, the insulators which are used in hilly areas, there is fog condition, and under this condition also the probability of failure is more. Therefore, pollution test in terms of salt fog test is performed, and there is salt fog chamber in which this artificial salt fog condition is created and insulator is tested. Next is testing of bushings. So here I have shown bushing. Now there is a difference between insulators and bushing. In case of insulators, conductor is either on the top or bottom, and earthing point of the pole is connected, or that is earth point through the pole or tower is connected either at the bottom or at the top. But in case of bushing, conductor passes through it. So bushing is used to take out the connections from the electrical equipments. So this is the point taken from the electrical equipment. So this is high voltage terminal, and this portion goes inside the body of the electrical equipment. For example, this is transformer. So inside this there are 3 phase bindings. So connections are taken out and they are going to the line, and this is supporting, and these are going inside this tank to isolate this conductor, these conductors, that is phase conductors, from the earth body. So that is the bushing. Now let us see what are the different tests performed on bushing. First is power frequency test. In this first is power factor voltage test. A is power factor voltage test. In this test, the bushing is set as in service or immersed in oil. It is connected such that the line conductor goes to the high voltage side and the tank of earth portion goes to the detector side of the high voltage sharing bridge. So this is performed through high voltage sharing bridge. Voltage is applied up to the line value in increasing steps, and then it is reduced. The capacitance and power factor, that is tan delta, are recorded at each step. The characteristic of power factor or tan delta versus applied voltage is drawn. I have already explained you the sharing bridge. It is used to find out basically the capacitance and loss factor. So loss factor is nothing but the power factor of the electrical equipment. So that sharing bridge, high voltage sharing bridge, is used to find out the power factor of the bushing. Then internal or partial discharge test. This is done to check the health of the insulator, health of the bushing. This test is intended to find the deterioration or failure due to internal discharges caused in the composite insulation of the bushing. So basically it is done to find whether there are partial discharges in the bushing or not. This is done by using internal or partial discharge arrangement. The voltage versus discharge magnitude as well as the quadratic rate gives an excellent record of the performance of the bushing in service. Now what is the discharge magnitude and quadratic rate? That I had explained in my previous video lecture. So that is obtained for the bushing, and that gives an excellent record of the performance of the bushing in service condition. Then momentary withstand test at power frequency. Bushing has to withstand the applied test voltage without flashover or puncture for 30 seconds. Now how much should be this voltage? That also depends on the rating of the bushing. In 1 minute withstand test at power frequency. Test is carried in dry and wet condition for 1 minute. So again, how much should be the voltage with the stand voltage, that depends on the rating of the bushing, and that is given in the standard. In wet test, RAM arrangement is used as in service condition. It is same as it is used for the insulator testing. The properly designed bushing should withstand the specified voltage without flashover for 1 minute. In visible discharge test at power frequency. Visible discharge means the discharge on the surface of the bushing should be visible. It is conducted to determine radio interference during service condition. Now see, basically when there is visual discharge means that is surface discharge. That comes under the category of partial discharges. Now when partial discharges are there, that is corona discharges are there, they generate some frequency that causes the radio interference. So this test is basically conducted to determine radio interference by the bushing during service condition. It is conducted in dark room, otherwise visible discharge will not be visible. There should not be any visible discharges other than arcing horn and guard rings. Then impulse voltage test. First is full wave with a stand test. The bushing is tested with standard impulse voltage of either polarity. 5 consecutive full wave of standard impulse voltage is applied. If 2 of them flash over, then 10 additional applications are done. If the test object has withstood the subsequent applications of the standard impulse voltage, then it has passed the test. So this is the standard procedure, that is steps which are involved for full wave with a stand test. Next is chopped wave with a stand test. Now why chopped wave with a stand test? Now bushings are associated with the transformer. Now transformer is the first equipment which is connected in the substation. So when lightning over voltage is coming or switching over voltage is coming, it is the first equipment which has to face this. And to protect this transformer, there is lightning arrestor. So lightning arrestor will discharge the lightning over voltage. Now when it is discharging the lightning over voltage, the impulse wave will be chopped down. When it is chopped down, there is possibility that rate of rise of the voltage, that is residual voltage which is appearing across the bushing, basically bushing and transformer, is high, and this can damage the insulation or bushing. So to ascertain that the insulator, bushing, etc. must be capable or should not break down or should not be affected due to this chopped impulse, the chopped wave with a stand test is carried out. Sometimes done on high voltage bushings, that is 220 kV and 400 kV and above. Switching surge flashover with standard switching impulse voltage test is conducted for high voltage bushing. This is also carried out in the same way as above full wave with stand test. The last is temperature rise and thermal stability test. It is performed to observe the temperature rise and to ensure that it does not go into thermal runaway condition. Temperature rise test is done at ambient temperature, that is below 40 degrees Celsius at a rated power frequency. The steady temperature rise should not exceed 45 degrees Celsius. Test is carried out for long time. Temperature should be constant or increase in temperature should be less than 1 degree Celsius per hour. This test is enough to produce large dielectric loss and thermal instability. Thermal stability test is done for bushing rated for 132 kV and above. It is carried out on the bushing immersed in oil at maximum service temperature with 86% of normal system voltage. This is a type test for low rating and routine test for high voltage rating. Friends, that is all about testing of bushings and insulators. If you feel this video lecture useful, then please like it, subscribe to my channel, ask your friends, colleagues and juniors to subscribe to my channel for video lectures on high voltage engineering and power system protection. If you want to make effective and efficient use of time, then read my book on time management. This is the link for the book. It is also given in the description box. I have launched a useful course for the students on UDEMY. Title is Accelerate Your Learning by Power of Visualization. This course is very useful for the students who are preparing for entrance and competitive exams. The link for the course is also given in the description box. This is the link and it is also given in the description box. Thank you.